welcome to the deep dive. Today, we are locking our focus entirely onto a single, very high-stakes day in artificial intelligence, December 29th, 2025.
And it was quite a day.
Oh, it really was. I mean, the headlines are just dominated by these launches of hyper-efficient new models, which are, fundamentally redefining what frontier AI even means.
Centered around Google's Gemini 3 Flash, of course.
Exactly. And at the same time, on the hardware front, a massive, strategically complex $20 billion deal just reshaped the entire silicon landscape for years.
And then there's the policy side.
Right. And that's maybe the most complex story of the day. We're seeing the U.S. regulatory picture descend into this sharp conflict between federal mandates and state-level governance.
That tension you mentioned is exactly what defines today's news. When you look at the sources, you're constantly seeing this collision. Technological perfection really meeting organizational imperfection.
A perfect way to put it.
So our mission here is to give you a really precise, synthesized view of this shifting environment. We'll trace the story from the lab breakthroughs, the truly remarkable advancements, all the way to the messy reality of real-world deployment.
Where we see some pretty critical failures in governance and oversight.
Exactly, especially when you try to manage these new AI agents at scale.
Okay, let's unpack this. We should start in the lab in segment A, where the research and the model updates are screaming one thing.
What's that?
You no longer have to sacrifice intelligence for speed.
That is the core message. Look, the headline event is the debut of Gemini 3 Flash. This model is, it's engineered purely for efficiency. It's pushing that performance to cost ratio to its absolute limit for developers.
And what's so fascinating here is that historically, cutting costs meant cutting corners on deep reasoning power. That was always the trade-off.
Always.
The numbers confirm that boundary is just gone. Gemini 3 Flash achieved an impressive 90.4% on the GPQA Diamond benchmark. For context, that's a score confirming PhD-level reasoning.
But here's the strategic part.
This is the nugget. This frontier-level performance comes in at less than a quarter of the cost of the older, bigger model, Gemini 3 Pro.
And that cost reduction isn't just a minor improvement. You have to see it as a strategic weapon.
How so?
Well, when you reduce the running cost of complex reasoning by 75%, you fundamentally change the economics of every single AI product. Suddenly, tasks that were just too expensive to run at volume.
Things like personalized tutoring or really detailed data analysis.
Exactly. They all become economically viable for startups, for large companies, for everyone.
And it directly enables those next-generation AI agents we're hearing so much about, right? Because low-cost, high-speed reasoning means we can run these complex chains of thought that were just too slow or too expensive before.
Absolutely. The sources today specifically verified that Gemini 3 Flash is superior in autonomous software development tasks. It scored 78.0% on the SWE-bench verified coding benchmark.
Which is actually better than the more expensive Gemini 3 Pro.
It surpasses it. So if you're building an AI agent that needs to fix bugs or write functional code all on its own, this efficiency breakthrough is completely foundational.
So moving from general reasoning to a more specialized application, the impact of these large models on life sciences had a major announcement today.
It did. Google DeepMind and Yale University released Cell-to-Sentence Scale 27B. They're calling it C2S scale.
Okay, break that down for us.
Well, this is a 27 billion parameter foundation model focused entirely on single-cell analysis. And to understand why this is a milestone, you have to appreciate the just sheer complexity of single-cell data.
We're talking about analyzing the unique molecular signature of thousands of individual cells inside a tumor.
Thousands of them. It's a task that traditional bioinformatics really struggled with because of the volume and the noise in the data.
So what did the model actually do with all that complexity?
It didn't just analyze it. It generated a testable hypothesis for cancer immunotherapy. The AI essentially predicted a specific drug combination that could turn cold tumors.
Those are the ones that hide from the immune system.
Right. It predicted how to turn them into hot tumors, making them visible. And the experimental validation showed this combination resulted in a roughly 50% increase in antigen presentation in human cells.
That is the ultimate proof of concept for AI in drug discovery.
It de-risks multi-billion-dollar investments by validating these pathways so much earlier.
We also saw some updates related to system architecture. An academic paper introduced something called VL router bench.
Yeah, a new benchmark posted on arXiv. It's highly technical, but it's critical for the future of multimodal AI. It basically evaluates how well these vision language models choose between different components.
So how smart the system is about deciding which piece of code to run for a given request.
Exactly. This helps researchers design far more robust and efficient systems that aren't constantly running expensive, unnecessary processes in the background.
In a wrap of research, NVIDIA released the Nitrogen Gaming Foundation model.
Right. An open source vision action model trained on a massive, massive data set. We're talking 40,000 hours of gameplay data.
Wow.
And this really signals a movement toward agents that learn complex actions just by observing huge amounts of data without that slow, heavy process of traditional reinforcement learning.
Where the AI has to fail thousands of times just to learn one thing.
Precisely. Nitrogen shows strong transfer learning, so skills learned in one game can be applied to others.
All right, let's move from the lab to the market. Let's look at the products hitting users today in segment B. The theme here really seems to be the global deployment of these agentic tools.
And it's enabled directly by the efficiency models we just talked about.
Of course.
And Google immediately scaled its gains. Gemini 3 Flash is now the default for AI Mode inside Search and the Gemini app globally.
That is a tectonic shift. I mean, we are talking about instantaneously putting faster reasoning and a much better understanding of complex questions into the hands of billions of users.
Billions, all at once.
That is democratization of frontier intelligence at a scale we've just never seen. And it instantly raises the bar for every competitor who hasn't hit that efficiency threshold yet.
Meanwhile, on the enterprise side, there's this growing realization that AI agents are just proliferating without any control.
A bit of a Wild West situation.
It is, and that's driving new products. Microsoft introduced Agent 365, a platform designed to help IT teams centrally manage and govern all the AI agents across their business. It's a direct response to this urgent need for security and compliance.
And Google is continuing to build out the infrastructure for these agents to move beyond just a chat box. They released the Gemini 2.5 computer use model.
Right, a specialized model. It's optimized specifically to power AI agents that can interact with and navigate messy, real-world user interfaces.
So basically browsing the web and clicking buttons like a human would.
Exactly. And that capability is foundational for achieving true, practical autonomy. The model showed an 18% performance increase on a key benchmark, proving it can handle the, non-standardized chaos of the internet.
We also saw a great example of specific industrial adoption, AI moving off the web and into engineering.
You're talking about the 3M announcement.
Yeah, 3M is debuting its AI-powered Ask 3M Assistant and an expanded digital materials hub at CES 2026. This tool is designed to just accelerate material discovery for engineers.
And that's a practical application with a huge potential return on investment. Instead of manually sifting through specs, engineers can just ask the AI to find the optimal adhesive or polymer for their new design.
Okay, let's move to segment C, chips and infrastructure. This is where the hardware money is flowing, and today revealed a massive, geopolitically charged realignment around inference hardware.
This is the crux of the day's financial news, absolutely. NVIDIA entered a non-exclusive licensing deal and hired core executives from Grok.
Grok being the startup that specializes in these super-efficient inference chips, their LPUs, or language processing units.
Correct. And financial outlets are estimating this acqui-hire deal is worth approximately $20 billion.
$20 billion. For a licensing deal and some key talent, that's a phenomenal valuation. What makes Grok's architecture so valuable that NVIDIA paid that much to secure it without a full merger?
It's all about two things: the memory bottleneck and the strategic shift to inference. Training models requires extreme power, which is what NVIDIA's flagship GPUs do with high bandwidth memory, or HBM.
But once the model is trained, the commercial value comes from inference, running the model thousands of times a second for users.
And that's where Grok's LPU, which uses specialized static RAM, or SRAM, comes in.
Why is SRAM so important right now?
SRAM is faster, it uses less power, generates less heat, and crucially, it bypasses the global supply chain bottlenecks for HBM. So by licensing Grok's architecture, NVIDIA gets this key inference tech and the talent, and it sidesteps regulatory scrutiny and a major hardware constraint all at once.
A multi-billion-dollar bet on the future of low-latency inference.
A very clear one. And while the U.S. market focuses on this, China is pursuing a parallel strategy for silicon sovereignty, driven by the same realization.
Right. The Yongtian Lifei CEO, Chen Ning, stated publicly today that the agentic AI era demands a pivot to efficient inference chips overtraining GPUs.
That's their path. They see it as a way to potentially overtake global competitors. Yeah, there's a huge procurement of domestic hardware from Huawei,
The numbers are what? Over 40 billion RMB?
which is approximately 5.6 billion US dollars, committed to Huawei's Ascend chips in 2026.
And that $5.6 billion commitment is largely because the NVIDIA H20 supply has been suspended, isn't it?
It is. It confirms a major strategic shift toward domestic silicon sovereignty in China. It's accelerating their use of indigenous hardware as the core of their future AI infrastructure.
And back in the US, the need for this specialized compute infrastructure led Applied Digital to spin out its cloud business.
Merging it with EKSO Bionics to launch Chronoscale Corporation. It's a GPU platform purpose-built just for AI workloads.
So another strategic separation intended to accelerate growth in this hyper-competitive market.
And they have a strong foundation. Applied Digital Cloud generated over $75 million in revenue in the prior 12 months, so they're pivoting hard into accelerated compute from a solid base.
All right, moving now to Segment D: policy, governance, and safety. If Segment C was about hardware alignment, this segment feels like it's all about regulatory misalignment, particularly in the U.S.
Exactly. The central tension is this clash between federal and state authority. A new federal executive order directs the Department of Justice to form an AI litigation task force.
And its purpose is what?
To specifically challenge state AI laws that are seen as conflicting with federal policy.
So is this really about conflict, or is it a power grab by the DOJ to make sure the industry doesn't splinter into 50 different rule books?
It's likely both, but the immediate impact is a consolidation of power at the executive level. And the financial implications for states are pretty severe.
How so?
Well, those with laws deemed onerous, like Colorado's SB 205, they risk losing access to crucial federal funds, like the BEAD program, which provides major broadband infrastructure grants.
So it creates this enormous financial lever for federal policy enforcement.
A huge one.
But not all states are responding with paralysis. Delaware is trying a much more agile and experimental approach, launching an AI sandbox program.
This is a really proactive measure. Governor Matt Meyer signed a resolution to create this supervised testing ground. It lets companies pilot advanced AI tools under temporarily eased regulations.
It sounds like a pragmatic attempt to foster innovation while developing a governance framework through controlled experiments.
That's the idea. And globally, the frontier labs are focusing on catastrophic risks. OpenAI announced it's hiring a senior safety chief, a head of preparedness.
A role specifically to mitigate these high-stakes threats like AI-enabled cyber attacks and biosecurity risks.
The move really institutionalizes this focus on risk mitigation at the highest level, and the listed salary is $555,000 a year, which reflects the serious financial investment being made here.
Finally, in this segment, China is focusing its regulations not just on technical risks, but on psychological and societal harms.
They're drafting rules for emotional AI services. These rules target personality simulating AIs to mandate things like addiction safeguards and emotional intervention protocols. It's about preventing potential mental health risks.
So it's shifting regulation away from just data or output and targeting the psychological impact of, high persistent interaction with these AI systems.
It raises a really compelling question about our long-term human reliance on these deeply personal agents.
Okay, let's wrap up our news with Segment E funding, M&A, and enterprise adoption. The money is just flowing at historic rates to finance the infrastructure we just detailed.
Indeed. Industry reports today confirmed U.S. AI startups raised a record $150 billion in capital throughout 2025.
$150 billion.
It's a massive figure, and it highlights the sheer scale of this AI arms race. And the funds are highly concentrated. OpenAI alone raised a staggering $41 billion of that total.
And this capital is translating directly into these multi-gigawatt infrastructure deals. OpenAI and NVIDIA signed a letter of intent for a landmark partnership.
To deploy at least 10 gigawatts of NVIDIA systems for AI workloads.
10 gigawatts is a staggering commitment.
It secures NVIDIA's production pipeline and sets a new, elevated standard for hyperscale AI compute. But significantly, OpenAI is also taking steps to diversify its hardware risk.
Right. They announced a strategic partnership with AMD.
For the first 1 gigawatt deployment of AMD's Instinct MI450 GPUs, starting in the second half of 2026.
This confirms AMD as a legitimate competitor in the frontier chip space. It's a very mature, strategic move by OpenAI to avoid relying on a single vendor.
Absolutely. And on the customer adoption side, OpenAI announced it reached a milestone of more than 1 million paying customers globally.
Including huge firms like PayPal, Virgin Atlantic, BBVA, Moderna.
This really signals market maturity. It demonstrates successful deployment and return on investment across really diverse sectors, from finance to healthcare.
And yet, amidst all this massive scale and technological perfection, we saw a critical failure that perfectly illustrates what you call the governance gap.
We did. Anthropic's automated system canceled a paying Swiss cybersecurity client's account. No human review, no explanation.
And the result was the temporary loss of 80% of their project data.
It's an incident that just highlights the profound operational risks that enterprises take on when their automated decision systems lack procedural protection and human oversight. The system was perfect in its automation, but the deployment was organizationally flawed.
So what does this all mean for you, the listener? Today, we have 2 new tools ready for immediate use.
First, there's Google Anti-Gravity. It's their new agentic development platform that uses the speed of Gemini 3 Flash. It's now available via the Gemini API, and it's designed to help developers with rapid, iterative coding.
And the second?
Second, enterprises and developers can access the highly efficient Gemini 3 Flash model, as well as that specialized Gemini 2.5 computer use model through Google's Vertex AI platform for immediate production deployment.
And for our numbers of the day, we have 2 standout stats that really summarize today's news perfectly.
First, $150 billion. That is the record amount raised by U.S. AI startups in 2025, illustrating the massive financial commitment being poured into this frontier AI race. And second, 78.0%.
The state-of-the-art score from the efficient Gemini 3 Flash model on the SWE-bench verified test.
Exactly, confirming that model efficiency no longer requires a trade-off in complex agentic coding capabilities.
So today was defined by this technological triumph. Gemini 3 Flash, the $20 billion inference deal, the C2S scale oncology breakthrough. But these triumphs were just perpetually shadowed by critical governance issues.
From the U.S. federal-state regulatory battle all the way down to that severe Anthropic account incident.
Which brings us to our final thought.
This is the central tension you need to watch as we move into 2026. If the most advanced AI models can now operate faster, cheaper, and discover new cancer pathways, why are major technology companies still relying on unmonitored automated systems to handle critical user accounts?
That's a powerful question.
The technical challenge of building frontier AI, it seems easier to solve than the governance and human-in-the-loop challenge of deploying it responsibly.
A compelling thought that connects the lab right back to the real-world operational floor. Thank you for joining us for this deep dive into the sources of December 29, 2025. We'll see you next time.